The collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data.
Machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
Great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because it's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty, who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary. That is, the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
So the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person, where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly, right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it.
So, hello everyone. I hope I was not actually available for the first set of lecture series on electrical vehicles. Were taught in detail with respect to the theoretical portions, but now, as in when I'm available, uh, I would try to take it forward from the place where it was left by my colleague. So I will take it forward. With the topics of simulation uh, using answers for the electrical vehicles first. I'll maybe a day would be spent for that, and for maybe from the next class or from the next to next class, we will touch upon the autonomous vehicle and the autonomous vehicle majorly include the same things. Primarily uh, we would primarily uh, have an understanding about the autonomous vehicles, and thereafter we'll move into the aerial robotics, where, as you guys know, that in today's era, uh, the drones, the autonomous vehicles, which are aerially operated, which are controlled by the algorithm or the flight control system, is majorly used and into picture. So that's the thing that we're going to explore in the in the coming days of the lecture series. And we'll have an introduction and understanding about the same autonomous vehicle. And thereafter, we'll do primarily two projects based on that. So that is how I'm seeing the course at the moment from this point. Uh, so yeah, let us first begin it with the simulation part of the electrical vehicle that was left uh, in the uh, ongoing courses that was ongoing electrical course that was happening. So yeah, before that, let me give you my introduction. So my name is Akshant. I am having an so my education background is into aerospace. I have been working currently as a flight mechanics engineer, and yeah, so not from this teaching background, but majorly I have been interested into uh, studying or telling you guys knowledge about the same. So I try to give uh, the understanding about the same things from my end. I hope it would be beneficial at your end as well. But yeah, sit back. Let me share my screen and thereafter um, take you through answers fluent. And so in the last, so I have taken one more course before this with on the electrical vehicles itself. So that was majorly a 40-hour lecture course, which included all the things from the theoretical portion, the historical developments, and thereafter slowly moving up towards the technical expertise. And post that, we were in a position where we could uh, take up different experimental parts or experimental ideologies or experimental projects. So in that complete course, we have done around four projects in ANSYS and two projects in MATLAB and Simulink. So that that was a majorly a more elaborative course with more timelines that was being allocated to me, so that the explanation would have been much more in that scenario. But now, as we have a constrained amount of days and time left with us for this series, I the first the first portion of the complete coursework was taken up by my colleagues. So I don't think we have more than six lectures left for the coming completion of the course. So let me take you through majority of experimental portions rather than telling you the theoretical portion one by one. So what we are going to do basically is in this complete scenario, we'll be taking an electrical vehicle and do the aerodynamic analysis for the same, completely comparing the drag and how the drag is uh, getting affected and how we can just minimize the drag by changing the CAD geometries or changing the what to say the design of the same. So that is how we are going to take up this part. And thereafter, in the second autonomous vehicle series, we will be actually taking up the drone portion. We'll be taking up fixed wing and we'll be doing the aerodynamic analysis of the same. Before that, we'll be doing an aerodynamic analysis uh, of the airfoil section, and then thereafter we will be doing the um, analysis of a wing, and then wing with the control surfaces, the fuselage, the elevator, and the complete body, and then comparing it with the different class geometry like quadcopter, and suggest see how fixed wing in its aerodynamic performance is better than the quadcopters. So that is how we'll be taking it forward. So let me share my screen now. Yeah. So this is the workbench section of. I hope the other person who actually conducted the complete series would have introduced you with these kinds of work work interface of the same. So rather than explaining you everything in detail, I will bring on the project and then slowly take you forward with it. Let's see. As the theoretical portion has been already completed for the electrical vehicle, I won't be telling you much the theoretical portion, but rather I would suggest you to have a look at the technical things first. So the analogy how I'm doing it, and then thereafter I would uh, slowly progress with it. Yeah. Um, mhm. So this is the workbench interface of answers, wherein you can see the different modules which are available here. Modules like the fluent flow, the CFX flow, the fit solver, and everything. So majorly we have works related to the fluent flow. So if you taking this here and uh, and then slowly building on top of it. For that, let me take you some geometry. If you have products, so let me show you geometry of this thing. Let me take them first. So once it gets opened, I will just introduce you to the space game interface and then move forward. So please open.
Sir, can you please check once with your mic, sir? Actually, the voice is too low.
Can you hear me now?
Little bit
Okay.
better.
Okay. Okay. Yeah. Okay. Sure. Yeah. So it's better right now.
Yes, sir. Yes, now it's better. You can proceed.
Okay. Okay. So yeah, I'm just opening the chat geometry with the space game. Once that is done, then I'll takes you through the interface of the space plane, and then thereafter uh, you can proceed with the analysis part of the same. So this is a wing, so this was the challenge. Yeah. So once the CAD geometry is done with us, we can create an enclosure for the same. And after the enclosure and everything is ready, we can proceed forward with the next steps. Mm, So yeah, supposedly this consider this to be one of the geometries that we are having with us. So first, before going to the geometry, let me take you through different options that are there into the space plane. And once we that is done, we can look it forward. So uh, yeah, just give me a moment. Let me take the correct geometry also into the screen, and thereafter we can take it forward.
Sir, are you facing any issue?
Hello. Hello.
Hello. Sir, not able to hear you. Guys, I think there is some network issue with the answer. So let's wait for 1 or 2 minutes. Sir will rejoin.
Hello. Can you hear me now?
Sir, you're audible now.
Hello. Hello.
Yes, yes, sir, you're audible.
Can you hear me now?
Yes, sir, you're audible.
Hello. Okay. Okay. So sorry for the inconvenience. I don't know why the network is off.
Yeah, okay, sir, you can proceed further.
Okay. So it's stable, right? Now.
Now it's stable.
Hello. You can hear me, right?
Sir, I think there is some network issue at your end. So can you please try to rejoin from
Hello.
another Wi-Fi or a hotspot, something else, like keep your secondary option? Because in between we are not clear with your voice and it's creating disturbance actually. So we are not able to hear you properly.
Okay.
Dear students, sorry for inconvenience. Please wait for some time. So we are resolving the issue.
I think it's audible now, right?
Yes, now it's clear.
Okay. Okay. So yeah. Let me share my screen again. And yeah. So from here we are actually. Uh, so let me first introduce you to different means layouts here which are available, and thereafter we can move to the analysis on the electrical vehicles. So as you can see here, the first portion is the file one, where you can import new geometries, can save them into different extension files, and you can import and export them. In the design tree section, you have different options available with you, which For example, you have line, you have rectangle, you have circle. So in order to explain each and everything here, we can maybe uh, take take like this, and for example, you can create a line, and then you can build your geometry according to that. You can do that with a rectangle, circle, three-point arc, and everything. So I think this is a trivial information. We shouldn't waste our time into these things at the moment. Instead, we can see how to do the analysis of this geometry which is with us. So rather than doing it completely, we can take this geometry's outer section and create an aerodynamic surface out of it. So just a minute, Control C and Control V. So after that, let me actually delete these all sections. So it's not needed at the moment. We just have the curve with us. We create our own uh, solid surface out of it. So in the design section, you can see this full command. So full command, you click here. So first before yeah, the full instead you do a box select and pull and then pull it. So you if you want to do it for example, it's a 2 meter wing. Okay. It's a 2 meter wing. Okay. Or for example, it's a 1 meter wing. Okay. Do not it's a very big one. So it's a 1 meter wingspan, and then thereafter, let me see. It is a hollow thing, right? So let me first uh, click on this portion, and then click full. Select click this portion. Click full. Then this is approved, and then select the surface. It is complete. Similarly, you'll click here, select approve, and this. Similarly, click here, select approve, and here. Okay. So now these two holes are filled. So this is the one that you need to do it. So click on this inner surface and click on fill. Okay. This is now done. So this complete wing is a solid surface. You don't need to worry about changing of the surface from the unsolid one or a surface one to a solid one. So now we have that. Now click here and click on combine. This is now three bodies are there here. First, second, and third. Okay. So if you want, we can delete these two and maybe then fill this as well. So this fill, this fill. Okay. This is done. So now we have a way. Now let me take you to the mesh convergence parts of the same analysis. So before that, let me create the domain of the same range structure. So here there's an option for prepare. There is an option for enclosure. So yeah, and then you asked Santosh, you had some questions. You asked something to ask. Okay, this way you can just text it uh, on the chat. So let me create an enclosure for this. So instead of a full body, let me see. So suppose, let me see that this point is the one that is at the center. So let me click here and pull it up to this position. So, mhm. So now we have till this section. Now we'll create an enclosure with a symmetric plane. So prepare with an enclosure. This one, write your 2500 or else 1000. Use an for your information. See how to open the workbench. So yeah, so first of all, in order to open the workbench, so the workbench is under the full package of ANSYS. ANSYS, uh, so you have to install ANSYS, whichever version you want. So this is a ANSYS 2019 version. Similarly, you can install whichever version, like for example, at this point in time, it is 2025. So ANSYS 2025 R2 is actually the latest one. You can go to ANSYS, you can install the student version at your end, and uh, thereafter you can maybe uh, after installing the entire package of ANSYS, you click you write here after the complete installation, you write your workbench. Okay, so you click your workbench, and then you'll get to open the entire this workspace. This workspace. And then in this workspace, you pull this and bring it here, and thereafter you can uh, access it. I hope it is clear. Okay, okay, thank you. So, yeah, after this, let me take it. So, 500 on this side, uh, 500 on this side. This side is symmetric, so 0. This is 1500 is the back portion, is the front portion 500. Yes, 500. Okay. So now we have created the domain. So I'll explain what is the significance of a big domain. So let me first bring this thing up. So see, for example, uh, this you're creating a domain, right? So from this side, the air is coming. So this should be at a significant amount of distance from the surface of the wind, so that the after the air is flowing through this shear layer, it doesn't get disturbed uh, to the walls. So when the air is flowing, it doesn't affect. So this flow doesn't affect the boundary of the wall section. So that is why you keep the wall sections much away from the aerodynamic body that you're going to analyze. Okay. So that is the reason why you keep a distance in the inlet, keep very much distance from the outlet, because this is the inlet. But then thereafter you get a disturbed flow, and the disturbed flow gets settled down after a certain point in time, and you want to get a constant pressure outlet. So you don't want a varying pressure at the outlet. You want a steady pressure at the outlet so that your aerodynamic analysis will be made constant. So that is why you get a very far pressure outlet. You get a very significantly far from the aerodynamic body inlet, velocity inlet, and then thereafter your walls. So I hope this is clear to you why we are actually keeping the walls at a certain significant distance. And this is symmetric plane. So this is a symmetric plane, and everything that is done here on this side of the wing is actually replicated and it becomes a full wing about its origin axis. I hope we can get along with it. Okay. So now thereafter, so this is now we'll check the repair things. It is working fine or not. So we'll stitch it. There is no difference and no stitching problems. We'll check the gaps. We'll check the missing pieces. We'll check the split edges. We'll check the extra edges, and we'll check the exact edges. So everything is fine now. So now, yeah. So everything is fine. Now what we'll do is we'll subtract this body for physics and hide it. So this makes it a cavity region of this. So this is not a wing anymore. It is a cavity of the wing. So that the aerodynamic analysis becomes much more simpler instead of doing the analysis by wing geometry because it's a solid body. So why not create a cavity of it? Because we are dealing with external aerodynamics. We are not dealing with the internal flows actually. So that actually brings us to a understanding where uh, we can actually do the analysis of the cavity portion and do the same analysis, and then it actually matches with the wing geometry itself because it's a cavity and we are doing the external aerodynamics. I hope till the enclosure portion everything is clear. Can you please drop it in the chat if you have any confusions to it? And I think it is something. It has something to do with the analysis of the electrical vehicles as a continuation of what was being taught in the previous 6, 7 classes. So we'll take it up after this understanding. So I hope it is clear with you. Can you please drop it in the chat once? Or else any problem is there. So that is not a very worrying thing. So after that, we'll go to the mesh conversions, and after mesh conversions, we take the electrical car geometry as an analysis question, and then we'll compare the geometries of two different aerodynamic surfaces and see which one is more aerodynamically better. So can you please till that time you can let me know. So should I consider it as yes that everybody is on the same page, right? Okay. So after this, we'll go to the mesh convergence part. So this gets us to the closure of the geometrical creation of an enclosure, which is needed for the meshing portion, meshing point. So without creating a geometrical enclosure, we can't go to the meshing. So instead, we create a geometry, we get a geometry, we create enclosure around it, we create the boundary walls, and thereafter we take it to the meshing part. So now the meshing part. So in the meshing section, click on edit, and so yeah, here comes. So it's loading actually. So now this brings you the entire enclosure. So there's the inlet, there's the outlet, these are the walls, and there's the symmetrical piece, and there's the wing. Okay. Yeah. Now let me first name the things. First. Okay. Please ask. Uh, has anybody raised their hand? Please, can you ask? I don't see any questions coming from your end. Can you please write it? Okay. So let me name it. Uh, uh, select first here's phase, and then bring your cursor here and do the right click. Click on name sections and write it velocity index. Okay. Now this hit press control and this. These three are balls. So click hit here and write balls. And portion this is outlet. So this is pressure outlet. And this is symmetry. Okay. Now click here and do a box select inside mode. Instead of single select, do box select. And then this. So here, right, wing. Okay. Now everything is named here as per your understanding. So let me show you in the tree. So this is the velocity inlet, this is the walls, this is the pressure outlet, this is the symmetry plane, and this is the wing. Okay. Now, uh, after this, click here, and inside the mesh portion, now we are going to decide the elemental sections. So what is the element size? So we'll keep it 0.1 as the outer element size. So why do we do meshing? So meshing is basically the discretization of the entire domain into smaller sections or smaller regular sections so that you do the analysis of a single elemental section and then you integrate it over the entire domain. So it makes your computation problem much simpler and much more accurate as well. So if you are going to do the analysis over the entire body, it will take hell lot of time, hell lot of accuracy is needed to actually uh, compute the entire formulation of the problem. Instead, what you can do is you can do the analysis of a smaller section, uh, and then you can actually integrate it over the entire surface area. So that actually makes your problem much more simpler, much more easier, much more refined, and much more accurate as well. Uh, so yeah, so do it here 0.1, discretizing the elements, then sizing, inside the sizing, hit wing, and when you do 10 times smaller, so 0.01, let us first do. So we are doing a mesh conversion study, right? So mesh conversion study, so we'll make an Excel also. So what we are going to do, we are going to create iterations, uh, mesh size, elements, and quality. Or okay, we'll go come to these terms. So the first one is first. This that the mesh size is 0.1 for the 0.01. We'll keep the outer structure same only. So is 0.01. So let us see now how it behaves. We'll be doing the inflation layer. So inflation layer also will write inflation layer. Boundary height. Inflation boundary height is this will be the 10 power minus 5. 8 into 10 power minus 5. Okay. So this is the one. And number of layers, what we are going to keep is number of inflation layers. This we are going to keep as 18 or else 20. Okay. Now let me do the mesh property now. Sorry, for now into the go to the mesh, right click, insert inflation. In inflation, first you do the box select, single, here, and then in the name section, go and select the wing. Okay. Now in the smooth transition, if you're smooth transition, you right click here first layer thickness and do 8 into 10 minus 5, and number of layers is 20. And the growth rate is, you keep it 1.2 itself, or else you do it 1.1. And here also you do it 1.1. Okay. So everything is now 1. Here also 1.1. Now you generate a mesh. So now your mesh is getting generated now. So let us see how the mesh quality will look like. So, what happens in the mesh convergence study? So, in the mesh convergence study, what we basically do is we take three different meshes. First is the coarse mesh, second is the medium mesh, and third is the fine mesh. So, we take a coarse mesh, we see its skewness and orthogonal quality. Then we move to the medium mesh, we see the quality. Then we go to the fine mesh. And then basically mesh convergence study is a study by which we get to know or understand what is the minimum requirement of the element size that you have to keep so that your results become stable and doesn't fluctuate with the so actually it doesn't fluctuate much with the size variation or with the element size variation, your results, the final fluent results, doesn't fluctuate and it becomes converged. So it becomes, so for example, you lift and drag, for example, in the wing case, it becomes constant. It doesn't fluctuate with the kind of changing in the mesh size. So after that minimum quality value, uh, howsoever you make it more finer and finer, your results will be the same. That is basically to help you understand the intensity of the mesh and also to help you get an idea about what is the required amount of sizing that you need to keep in to make your analysis accurate. Yeah. Now, let's see what is the amount of elements. So this is the number of elements, 73,000. So let me write it here now, 73,000. Now, what is the quality? In the quality section, we'll go to the mesh matrix and we'll see the skewness. You see, this skewness is basically, so skewness should be closer to 0, and actually your orthogonal quality should be closer to 1. So the more your orthogonal quality is closer to 1, mesh is that much fine. The more your skewness is closer to zero, it is more fun. So see, here it doesn't make any difference. So everything, your mesh metric is closer to zero only, less than 0.5. So your mesh stands converged only. As it is a very simpler geometry, it doesn't require more and more refinement. So we'll do one more for the sake of completion. But I think this so you can see here, right? So let me take a snip of it. Yeah. So I just wanted to show you that इसके बाद if we further do the mesh refinement more and more, it doesn't actually change anything. So rather than actually actually putting constraint or stress onto your mesh structure by increasing the completion time, you can go with the coarser mesh only, which we have kept here. So we just keep it as a reference for you to take a look at, at the latest. So now we'll keep the inflation rate same, but we'll do it smaller. So instead of this, 0.005. But you will see that the mesh matrix will remain more or less the same only. It doesn't fluctuate towards the higher end. So it may show you with an understanding that your mesh quality is actually restored to the better situation. Now, remove the mesh with refined geometrical section. Yeah, machine the solids. See, here also, as I told, nothing got changed majorly. So, but your mesh elements would have been increased to a significant amount. So, let me first complete it. So, there's k iteration, 20 layers itself. This is 0.00008. This is 0.005. And let us see the number of elements here. So, it is double, more than double. So, it actually increases the computational time as well. That is not required. Either mesh, let this show you the comparison. I mean, more or less on the same ballpark. See, the quality is actually restored itself with the uh, un, not so final quality of mesh, but still. So yeah, it is what to say, less than 0.5, less than 0.5, less than 0.5. So as per your mesh convergence criteria, says your quality is restored. So now we'll actually go back to the coarser mesh only, as it is constrained itself. So let me first let me do one thing. So it's a very fine case. Let me do both the meshes to show you the results also, that the results are also not changing. So currently I'm showing you the state of mesh, but I did not get any response from your end, so should I consider it a yes that you don't have any doubts regarding the same? Can you please let me know before we move further to the fluent section setup of the problem. So what I'm trying to do is instead of doing a doing straight away showing you that the coarser mesh is a refined mesh. I am actually comparing it with the coarser and the finer mesh to show you in the result section itself that both the meshes after getting converged shows the same results. So instead of explaining it the problem uh, uh, verbally, I'm trying to show you both the comparisons at the same time to help you understand that the results are converged as per the mesh quality. So you don't have any problem, right? And everybody can hear me properly, right? You can hear me properly, right? Hello? Hello? Let me open the Fluent section now. So is in the Fluent section, the setup portion, we can see here the double precision. So I pick up that box and I'll do the parallel processing so that the uh, solving capability of the complete thing gets faster. So it becomes faster. So I'll increase the number of solvers to 4 and then I'll start it. So now it is starting. Now, so we'll do a very simple problem. So we are going to take a very simple problem. So not too much of uh, not too much of this thing, complexity in the problem. We'll only give a forward velocity. We'll do the generic thing. So you see. So yeah, so here you can see here. Uh, so Z direction is positive facing above the wing, right? So this is the wing section. So this will do minus 9.81. That is gravity against the gravity. Now the velocity will take only 20 meter per second. So not too much difference will take. Will take just 20 meter per second. We'll take the wall boundaries also as 20 meter per second. So moving walls so that um, it doesn't create a shear difference between the motion of the air near the walls to the motion of the air near the surface of the wing. So everything gets to constant motion of the air throughout the entire inlet portion. So that is why we are giving the moving wall absolute condition to 20 meter per second, same as the inlet force. So that I'll show you here. So that supposedly this is your inlet, right? Yeah, so everything gets to 20 meter per second. Okay, everything gets to 20 meter per second. So it doesn't happen to be a parabolic distribution. It happens to be a constant distribution. Otherwise, if this is not the moving wall, so this portion and this portion will experience a zero velocity section, right? And a maximum velocity section. So instead of a parabolic distribution, we are doing a constant distribution over the inlet to give a complete atmospheric scenario instead. Not so to replicate the entire atmosphere without considering it a wall, and these are moving gas. So now take this inlet, we'll go to this project areas and think about the z-axis compute. So this is the area of the wing. This is here. And then if the this thing one itself inclusion. So this is basically the length of the turbulent length of the entire biggest aerodynamic surface that is facing the inlet. So when the air is moving uh, along the flow of the air, the longest aerodynamic body is given as the length. So in this section, the longest aerodynamic surface is the wing, and along the flow region, it is the chord of the wing that is coming as the longest portion. Now you see the CD. So then we CL. And CL of the wing. So this is the wing. This, this. Okay. Now we'll do the initialization. So initialize for the wing. So we are initializing the term. So in the initialization section, it is actually solving the Poisson's equation. So I think grad dot p. I think you guys know the Poisson's equation. So that Poisson's equation is solving to actually formulate the problem for setting up the analysis. So now we'll set up the analysis. So 100 will be the calculation. So it is calculating now. It will do fast only. So once the results are done, we'll note the results and then we'll do it with the same thing, do it with the cursor mesh to compare the results. So it's happening right now. It's taking some time, but still it will function fast only. So let us see the plots. This is the F plot, CL plot, and this is the CD plot. But it happens for around 20 iterations. I think in 20 iterations it will converge only. So no need to go till 100 iterations. Rather, I'm waiting. We can close it up here only and then do the analysis for the Coursera machine on the same lines of 20 meter per second, everything same. And then we'll compare the results. So the first thing that you are seeing here is continuity. Continuity. This is the x velocity, this is the y velocity, this is the z velocity. So black one is the continuity. So I have kept the convergence criteria as when after solving the Poisson's equation, when the continuity reaches 10 power minus 4 and xyz velocity reaches 10 power minus 6 as their benchmark value, then the solution is tending to be converged. But also, we'll view at the plots. If the plots are going on the finite direction, that means that our results are actually converged. So we'll wait for a few minutes. I hope everybody is understanding how I'm setting the problem. Can you please drop a message in the chat if you have any doubts or if you're understanding it properly? Can you please say till the time it is converged? Yes, can everybody please let me know if you have any doubts or problems? Also, Amar, can you please let me know again if you can hear me properly?
Now it's okay, sir.
Just it's working, right?
Yeah.
Amar, it's fine, right? Okay. Yeah, so it is getting converged. Uh, Let me show you up here. It's an almost follow a cyclic pattern now, but yeah. So I think it has reached to a point of thing. Uh, we'll just keep on repeating itself. So we'll take an average value and then move towards the next section. So we'll take the average value and then we'll move to the next section. Okay. So just a few more minutes. Maybe this would converge itself to a certain extent. So let us wait for a few more iterations, 20 more iterations maybe. And I think it will converge itself. So rather than closing it, let me bring till the time it is converging, let me also see the electrical vehicles that we are going to analyze. We'll do only one analysis of the electrical vehicle, not more than one. Yeah, so that is something that we already know. So let it get converged. And by the time I am also getting the CAD for the electrical vehicle that we're going to do after this complete mesh convergence study, and then we'll move to the autonomous vehicle. That is the area autonomous vehicle. Yeah, so just just a minute. I think it is converged only. Yeah. All it, hold up here. So it is more or less uh, same ballpark line itself. So we'll not try to look whether we can close it, and then we can compare the results. So that I just wanted to show you how the mesh convergence is approached. So two different problems, and then seeing that the results vary that much or not. So you see the value of drag, and you will see the value of lift. So you will these two things will note it. This is the first case. This is the this is the final mesh. Okay, this is the final mesh. Now we'll go to the this is done. Now we'll go to the coarser mesh. So before going to the coarser mesh, let me update the mesh here. So what we were doing, we were taking here 0.01, right? 0.0. Then mesh it. Let it finish. Yeah, it is done. So this we can update it. So after that, updating it. Let me open the fluent section again. So it is like that. Okay. So I'm not showing you the post processing of the results at the moment. Just showing you the so post processing and everything. I might show you in the AV section, autonomous vehicles section, or electrical vehicle section, which we'll be doing in the coming class. Uh, but yeah, that is not a bigger. You need to understand the setup of the problem properly, and rest of the things, yeah, you can do. Post processing is not a big deal. If you are setting up the problem correctly, your results will be fine. You just need to understand and learn how to read or interpret the results, whatever you're getting. So that is the one. The opening fluent. Parallel. Yes, so now, yeah, getting so we will be doing the analysis based on. So this was also important because I don't remember because I don't know what all the my colleague has actually explained you on the answers portion. So I'll take you through the understanding of electrical vehicle into uh, answers, how we are actually building up the problem or setting up the problem and doing the analysis. That is the secondary stage. And maybe in the next class, in tomorrow's class, only we will also start the autonomous vehicles. So autonomous vehicles PPT also I am actually having it with me. Um, I wanted to start that only today, but I thought it's better of a deal to actually give you a brief understanding about what the things happened actually in terms of answers, and then maybe take it forward to the autonomous vehicle. So yeah, yeah. This is 9.2. Yeah, I'm not going to explain you the turbulence modeling, that a separate course for 20. So yeah, you remember that we are doing uh, the basic turbulence modeling itself. It's 20. 20. And the turbulence modeling, we will take it as K omega SST. Okay, this shear stress transport theorem. Now, the next question, 0.7. Uh, yeah, so 0.17 and 1, and then your enclosure. Report definitions. In the report definitions, you click on graph, click on CD, go here, that's it, this, then lift, here, go here, done. So now Initialize, solving the positive question. Locally initializing by using standard initialization instead of hybrid initialization, taking random values. You tend to solve the positive question locally using a standard initialization process. Okay, so this is done. Now setting up the problem under iterations, and then now it's calculating. I hope things are clear at your end. Can you please drop a yes if things are clear at your end as well? Whatever I'm actually trying to explain you in the mixed convergence study and all these things. So base of whatever lies within the uh, ANSYS fluent setting up the problem. Can you drop a yes if you don't have any problem and you're okay with the understanding? Hello, Amar, can you hear me?
Yes. Yes, yes, you're audible.
Sure. Yeah, so it is running. Now, let it run for a few more iterations and then we can conclude it by uh, concluding the mesh convergence methodologies. And that one, the one that we did just now, that was not on uh, the Omega system model. I think we did it on um, red laminar flow condition. So let me do this, record it, and then we'll do that again. Because you saw there it was so much a problem in the convergence criteria. That was because of that reason. Because it was forcefully solving the laminar equation, but it was a k omega SSP problem. So that is why let me complete this and then maybe do that again. Here, the convergence is so quick and so nice, beautiful. Uh, okay, so yeah, this is done. Let me record and just for drag on this. Then done. Okay, so record this for you. And this one you don't see right now. So this is of course this. Mm, okay, so this let us delete it right now. Let me again do it. So this is done. Now take the mesh portion, do it to 0.005, 0.005, and then again update it. So with the mesh, I mistakenly did it for the laminar case, but it is not a laminar flow, it is a turbulent flow itself. So turbulent flow, laminar flow, you decided by calculating and deciding on the Reynolds number. The Reynolds number is the case of a flat plate, and that is how you actually tend to understand that whether it is a flow that is a laminar or turbulent flow. So yeah, it is actually meshing right now. Let it mesh, and after that we'll set up the problem quickly again and see if the results are accurate or not. And that will bring us to a conclusion that the mesh is converged. And we can take a coarser mesh itself to formulate the problem instead of finer mesh. Certainly increasing the computational time, so that is not required at the moment. So yeah, so well done. Now close this. Maybe instead of that, we reset. Okay. And I'll do that. Work decision, otherwise, this will be a repetitive task, so I'm not actually repeating it. So for turbulence modeling is another task that needs to be studied if anybody is interested into aerodynamics or computational fluid dynamics. Uh, and that is a very important, interesting topic. So I did it, I studied it in my higher education course, and I took it as a separate course itself, turbulence modeling. So turbulence modeling is really interesting, and you need to understand the physics very properly, the flows very properly, how the flow is moving, in order to get an understanding about the turbulence modeling. So it is very interesting. I would recommend you guys to actually have an understanding of the same. Read it on your end, and yeah, and maybe it would help you in your career. So yeah, now yes, management from 50. So yes, you just for mistake that I did. So was SSP. Well, I thought the why does not converge on what is the problem? It's a very simple problem. What what the heck is happening? So 20 second, then 20 again here. And the adjacent walls and reference values to do it inlet to 0.16. So they are using what PLA, PLA, and this is along the red axis for the protocol. Okay, those initialize solving the coordinate situation locally along the inlet, starting from the inlet. So um, okay, one second. One second. So now overwriting it. Let's see now how it is behaving here. not speaking at the moment. I'm allowing it to converge. So I'm doing a repetitive process actually. So here, so whatever we did for the mesh conversion study in the finer mesh, we are doing it in the coarser mesh. We are doing it in the finer mesh as well with the same turbulence modeling of K omega SSP, and then we'll compare the results here, whatever we got, and we can conclude that whatever element size that we're having, we are actually fine with it. So, am I clear, Sakshi? Uh, whatever I said, is it fine? So, I'm allowing it to converge at the moment. I'm not speaking anything. I'm not speaking anything. So, yeah, just let it happen for another 10, 15 iterations, and you'll get a clear understanding of how your lift and drag are actually proceeding. So am I clear, everyone? Can you please drop a okay if I made sense to this complete lecture series, into this complete, what to say, um, yeah, 2 hour lecture course. So we discussed how to use answers in doing a proper aerodynamic analysis, starting from the domain creation to the mesh conversions and everything. So that is how proceeding. So, so it's happening now. Let it happen for another 20 iterations more, and then we can conclude it. Yeah, so let it happen for another 20 more iterations, and then we can proceed it or conclude it with a statement of understanding that the mesh is converged on, or we needed to go to a final. So that is how I think it is converged. So, yeah, can you please ask whatever is your doubt? Please, this is done only. So 8, 9 more iterations let us do, and then we can conclude it. On 50 days profit is coming down itself. So that was a better mesh, I believe. rather than this, because this is going with certain amount of fluctuations as well into the solution of the problem. So it is not true also that you are doing a very fine mesh, so it will give you a very converged fast result. So a very fine mesh with a very much of a lot more of number of elements into it, embedded into it, will take more amount of time to actually solve it, and then it might be possible that it will face certain fluctuations as well before showing you the correct results. So that is also a case, but yeah, it has come to a certain point where you can stop it. So let us now record the results. Yes, and complete. So these are the two things. So yeah, so you can see here it is actually similar only on the similar lines. So you can not a problem. You can say that numbers, whichever you take will be a bit. It won't be much of a problem. So still, you take a final mesh. If you have done your analysis with a final mesh, you take out the final mesh. But any of the thing, whichever you take, it is fine on that aspect. So yeah, that's it from my side for today. I hope things are fine. You guys understood things which I tried to teach into today's class. It was majorly onto the complete understanding of the methodologies of to set up a aerodynamic analysis or a problem into uh, ANSYS, and then extract the results, do a mesh convergence study, and interpret your results howsoever it is making sense, um, and how accurate is your approach or methodology. So it is not a very detailed manner of how I actually try to explain you these things, but maybe you can take a reference of the 40-hour lecture course that was actually pre-recorded for turbulence modeling and everything. But yeah, I hope things make sense, and thank you everyone. So shall I drop a
Yeah, sure, sir. Thank you.
shall we close, Amar?
Sure, sir.
Uh, okay, sure. Okay, thank you everyone. You guys can drop. See you tomorrow. Bye.
Yeah, thanks. So, dear students, I already shared the attendance feedback link in chat box. So, I hope everybody marked the attendance. If anybody missed on that, I'm resharing over the Zoom and YouTube.
Shall I close the link from my side? Can you drop?
You can drop, sir. No issue.
Okay.
Yeah. So, if anybody missed on to the submitting their attendance, please mark your attendance and share your real-time feedback about the session. Okay. And we'll see you tomorrow at same time. Thank you. Bye bye and have a blessed day.